Center for Grapes. We value your partnership as expert partner. I'm Ami from Shimadzu, India, your host for today. Even though ethylene oxide is well known to be a toxic compound with carcinogenic concerns, it has been widely used as a fumigation agent in the food industry, even in sterilization for the medical devices in healthcare industry. Once in contact with food, EtO reacts and with the matrice and further producing a lot of reaction products which itself are toxic in nature. And hence, this is a matter of concern and food safety. The recent recall of food products exported to the EU due to have been recalled due to non-compliance with their regulations, and this has brought this food safety concern into the highlight, and also brought the need for also brought forward the need to analyze residue analysis. To ensure the food safety, quality of fruit products, the European Rapid Alert System for Food and Feed (RASFF) prohibits the sale of goods beyond the specified MRL values. To hear all about it, we invite our expert speaker, Dr. Banerjee, who is from, I'm sorry, I would like to please invite Mr. Mohan from Toshwin to just have some opening remarks before we invite our expert speaker, Dr. Banerjee. Mr. Mohan, please, could you unmute yourself and...
Yeah, good afternoon. Good afternoon, everyone. I think I'm audible. Am I audible?
Yes,
yes,
go
yes, please
okay,
go ahead.
Yeah, so at the onset, we thank all of you for your overwhelming response in joining our webinar on analysis of ethylene oxide and 2-chloroethanol in food and other matrices. Shimadzu and Toshwin have been partners in serving analytical instrumentation industry in India since last 50 years by consistently bringing in cutting-edge technology, providing innovative solutions, as well as highly reliable and prompt after-sale support. We have very strong presence in India across all market segments like food, pharma, chemical, government, and academia, and many others. Today, Toshwin has pan-India sales and service network spread through 14 branch offices across India, serving over 8,500 customers and installed base of over 15,000 instruments. So with this background, we once again thank everyone for your participation, and we look forward to a very, very informative webinar. Thank you. Amisa.
Thank you, Mr. Mohan, for the welcome remarks. Let's now straight dive into the subject and hear it from the expert. Dr. Kaushik Banerjee is the principal scientist from ICAR National Research Center for Grapes, Pune in India. He has widely published in peer-reviewed journals. Being a member of the Food Safety Standards Authority of India scientific panels and working groups on pesticide residues and methods for sampling and analysis, he regularly contributes to the development and implementation of food safety standards in India. His area of research focuses on the development of efficient analysis methods for sensitive and confirmatory estimation of contaminant residues in agricultural and food matrices, risk assessment studies for fixation of crop scientific maximum residue limits. he would be enlightening us with the regulatory perspectives of ethylene oxide analysis in food commodities. The stage is yours, Dr. Banerjee. You can unmute yourself and make your keynote address for this session.
Thank you very much, Amy, and it's always a pleasure to be a part of such webinars. So my name is Kaushik Banerjee. I represent ICAR National Research Center for Grapes, which is also recognized as the National Reference Laboratory on Pesticide Residues and Mycotoxin Analysis in India. I welcome you all to this webinar, which is jointly organized by ICAR National Research Center for Grapes and Shimadzu Analytical India Limited. And we have scheduled this talk as a part of the Azadi Ka Amrit Mahotsav celebration. You know that India has achieved 75 years of its independence. So it's a very special year. And in this, such kind of technological talks are extremely important. So I have a short presentation. Let me first share my screen. Okay. In this introductory talk, I'm going to present the regulatory perspectives of ethylene oxide analysis. You know that ethylene oxide in recent years has become a highly talked about subject, not only in India as well as many other countries. Ethylene oxide, as Amy has introduced to you all, that it is a fumigant compound, which is mostly used for sterilization purpose or disinfection purpose. So what happens if a food item is treated with ethylene oxide? It basically eliminates any microbiological contamination which may be present on its surface. And this way we can get rid of certain organisms which creates a lot of food safety problems, for example, salmonella. But the problem is ethylene oxide as a compound, toxicologically, it is carcinogenic in nature to human as well as animal health. And it is also classified as a category 1 carcinogen by the International Agency for Research on Cancer. So what happens that if a person is exposed to ethylene oxide on a long term, then there is a possibility that it may cause cancer. And people have also reported probability of its mutagenic effect. So these are the reasons why it is not permitted for disinfection purpose of food items, whether it is in India or any part of the world. In the European Union, a scientific committee on food on 6th May 2002 concluded that the presence of ethylene oxide in food could be highly toxic to a consumer's health. And even if animals are exposed, then it causes a lot of trouble to animal health. And hence its residues should be brought below the detection limit. That means if the sample is tested for ethylene oxide, then basically its residue should not be detected. So that is a very clear-cut thing. And since ethylene oxide is basically a non-recommended chemical, so it does not have any risk assessment based maximum residue limit. So it is always regulated as the limit of quantification. So when a food matrix is fumigated to get rid of any microbial contamination, ethylene oxide gas reacts with chlorine ions, which may be naturally present because of many reasons. And it forms a compound named ethylene chlorohydrin or 2-chloroethanol, which is popularly named as 2C as an abbreviated term. So in many cases, people have reported also that 2C may be also produced as a result of some other exposure or from other sources. So detection of 2C or ECH in food indicates the history of fumigation by ethylene oxide. This one part is true, but another part is also true that this may also get created from some other sources. But residue definition in every country, they say that when ethylene oxide has to be tested, it has to be tested along with 2-chloroethanol because ethylene oxide is a gas. So when it reacts with chlorine, you will find that a substantial component of ethylene oxide gets converted to 2-chloroethanol. So only analysis of 2-chloroethanol does not solve the problem. In the European Union, ethylene oxide is prohibited from any use in plant protection products. In biocidal products, ethylene oxide may be used as an active substance for disinfection purpose. This means that certain physical surfaces can be disinfected by this, but food contact is not allowed. The raw materials used for the production of food additives have to comply with the maximum residue limit set by regulation EC 396/2005. And since risk assessment based MRL is not available, the European Union reference laboratories, they initially proposed that there should be a consensus based limit of quantification, which was initially decided at 100 ppb or 0.1 milligram per kilogram, which basically reflects sum of ethylene oxide and 2-chloroethanol expressed as ethylene oxide. That means you cannot sum their residues. You have to estimate ethylene oxide, you have to estimate 2-chloroethanol, then you have to convert 2-chloroethanol residue to ethylene oxide, and then arithmetically sum them. But recently the regulation has got changed, and here you can see that this is the screenshot from European Union website. You can see that MRLs were initially set at 0.1, but currently these MRLs have been brought down. In many cases, these are 0.02 or 0.05, and in certain commodities, it has also been maintained at 0.1, which probably indicates that multiple factors that affect the limit of quantification of any substance in any matrix. So rapid alert system on Europe, which creates a maximum problem for the international trade to Europe. You know that rapid alerts are issued in Europe as and when the residue levels are reported at a very high level, which exceeds MRL or exceeds the regulated in limit. So in this case, basically the overview of rapid alert notifications for ethylene oxide during last 1 or 2 years, you see that most notifications were related to sesame seeds and the products containing sesame seeds. In 2021, a greater variety of products was also reported, which included locust bean gum, food additives, food supplements, and spices. So you know that these are the typical commodities which has microbial infection possibilities, and people might have treated them with ethylene oxide, which was detected when these were analyzed by laboratories. The food additive locust bean gum, which is mainly a thickening agent or stabilizer, is used in foods like, for example, ice cream, breakfast cereal, meat products, confectionery, fermented milk products, and cheese. So many of us consume such kind of commodities. So it is not always true that only the products containing sesame seed will have ethylene oxide. There could be many other items which might have got treated with ethylene oxide, and they get reported in such commodities. For ingredients with residues of ethylene oxide above the MRLs, all the European Union member states clarified that competent authorities withdraw such products from the market and recall them from consumers. Many of the reporting countries have also confirmed the same approach. The products are either withdrawn or recalled in case the commodities contain a contaminated ingredient. So for example, there are breads, there are cakes, which may contain such kind of seeds or products which may get exposure to ethylene oxide, regardless of their ethylene oxide content. Other countries reported using a risk assessment approach. Sometimes it is also seen in some cases. For example, the German Federal Institute for Risk Assessment, or BFR, they came out with an approach, but these are very specific things. So what German authorities has done, they have derived an intake level of low concern. That means that this is the lowest level, which may not cause much concern to human health, and that is based on the large assessment factor approach. This is a method of the European Food Safety Authority. The approach principally serves as a tool for risk management for prioritizing risk reduction measures with regard to scope and urgency. The approach calculates the amount of substance for which, even in case of a lifelong intake or lifelong exposure, the additional risk of contracting cancer is unlikely to exceed 1:100,000. So for ethylene oxide, this German authority has calculated this intake of low concern to be as low as 0.037 microgram per kilogram body weight per day. So you can imagine that this level is too low from the context of exposure and toxicity. So let's briefly discuss about India's story. In India, ethylene oxide treatment of food is not permitted by Food Safety Standards Authority. So it is not officially permitted for application in food. In the year 2020, ethylene oxide residues were notified for the first time through the rapid alert system of Europe in certain batches of sesame seeds, which were exported from India. First incidence of product recall of sesame seeds was around September 2020, but in the next 6 months, a huge number of rapid alerts came up. So almost 500 plus products were recalled. And this caused a lot of hue and cry and a lot of financial loss to the exporters. The exporters either had to pay more to ship the products back to the country or destroy the contaminated consignments. So as a result, a new regulation of the European Union, EU 2020/1540 was introduced on 22nd October 2020, which commended that all imported sesame consignments from India must be analyzed for the residues of ethylene oxide. So subsequently, the regulatory agencies felt that the other agricultural and food products might also require routine testing of ethylene oxide for export certifications. So this reflects an anticipated huge sample load for the food testing laboratories, because even NAPEDA, EIC, they always feel that many of our commodities may require ethylene oxide testing. And since we don't have any background information, so initially some samples need to be tested to check whether there is a requirement of testing such compounds or not. In India, you know that Indian Oilseed and Produce Export Promotion Council, or IOPEPC, they ask for mandatory testing of ethylene oxide, and to see the labs required to include both compounds in the accreditation scope, and it has to be reported in terms of regulatory guidelines. APEDA, EIC are expecting a routine testing of all fresh and processed commodities for ethylene oxide. We had a stakeholder meeting in Pune last year, and it was decided that we need to evaluate the risk before making it compulsory. So if there is a risk, then only such kind of compulsory testing or mandatory testing may be required in other commodities. So what happened that it was decided that NRL of NRC grapes will do some samples randomly and check. So what we are currently doing, and based on that, probably future ideas, especially regarding fruits and vegetables, will be decided. Ethylene oxide is a volatile compound at room temperature, but 2C is not that volatile. So if the method of analysis is not adequately optimized and validated, their recoveries are often not consistent. So for regulatory compliance, both ethylene oxide and 2C should be tested with satisfactory accuracy and precision. And since ethylene oxide is itself a gaseous compound, it's not easy to have good recovery for such a gaseous substance. A separate reference standard would be required, out of which 2 separate calibration graphs have to be constructed. The residues of 2C has to be multiplied by a factor 0.55, which is basically derived from their ratio of molecular mass. And this will come out with the actual equation by which ethylene oxide and 2C can be added and combined residue can be reported. Ethylene oxide, I have just a couple of things to add, that ethylene oxide, basically analysis can be performed by various ways. And this may include liquid injection. This may include one dedicated instrument. This may include headspace injection. So in today's webinar, my colleagues from NRC Grapes, NRL, and Shimadzu Analytical Laboratory They will be demonstrating how efficiently both ethylene oxide and 2C can be estimated by GCMS technology. So please prepare yourself to learn it through a video system, so that you can really witness its analysis online. So I really appreciate the effort of Shimatsu for dissemination of this knowledge. And I wish that this program will be highly interactive. And please prepare your questions, and in chat box, probably you can ask such questions, which we can take up at the end of the program. Thank you very much, and wish you all the best. Thank you.
Thank you, Dr. Banerjee, for setting the tone of the session and providing us the detailed overview of the regulatory implications in place for EtO analysis and residue contamination. It's a good time for a poll. Can we have the first poll question to just capture a few of your responses? I hope you can view the question. Do you feel Shimadzu should have more sensitive method for analysis of anticipating regulations might further reduce the LOD, LOQ levels of EtO and 2CE in foods? We'll take another 5 seconds. Please punch in your response to this poll so that we can understand. Okay, we end the poll now, and to share the results, we have almost 80% who say yes. So we do need a very good sensitive method that helps in this analysis. Your request is what we have been already working on. Shimadzu has been doing a lot of work towards developing the best suited methods for this analysis, and especially for trace level in various matrices. I would like to now invite Dr. Jitendra Kelkar, who is the General Manager of Customer Support Center at Shimadzu, India, and he will take us through the application perspective. To introduce Dr. Kelkar, he holds a doctorate degree in chemistry and has overall 30 years of impressive experience in the analytical field. He has been heading Shimadzu India's Customer Support Center at Mumbai, New Delhi, and also the Application Support Development Center, which is at Navi Mumbai, since 2008. He has been leading a team of almost 22 application scientists here, and his focus has always been to support customers all over India for troubleshooting, method development, technical consultations for chromatography, mass spectrometry, and spectroscopy. His expertise in handling advanced cutting-edge technologies has led to developing various novel methods for challenging applications in various wide range of segments such as food safety, flavor and fragrances, chemicals, agrochemicals, pesticide residue, and various other FMGC applications. He has many paper publications, articles, posters to his name in various national and international journals. He's also a member of the AOAC and AOAC India section. Dr. Kelkar, invite you to share your presentation.
Thank you very much, Amisan. And yeah, thanks for the introduction. I will just share my screen and will start my presentation. I hope you all can see the screen. Just a minute. Today in my presentation, I will be covering various solutions proposed by Shimadzu to analyze ethylene oxide and 2-chloroethanol in various food matrices. Now, as we all know that the importance of accurate identification and the quantitation of ethylene oxide and 2-chloroethanol in food commodities before they are being exported to the European countries. In this presentation, we will try to understand what are the challenges in analyzing these two compounds in food and what are the possible solutions. Just to begin with, we will take a quick glance at MRLs set by the European regulations for different commodities. From this table, it is very clear that the lowest MRL requirement is 20 ppb for fruits, vegetable, pulses, and cereal products. Considering this, we need to target the LOQ of at least 50% of MRL, that is 10 ppb. In this presentation, I have taken sesame seeds as a representative matrix for which various methods have been developed. Although sesame seeds fall under the category of oil seeds and has EU MRL requirements of 50 ppb, we have targeted 10 ppb LOQ in all of our methods to prove the reliability of the method. To understand what are the challenges in analyzing these compounds at lower levels in food matrix, we need to understand the physicochemical properties of these two analytes and their possible interferences. This can give us the fair idea about what solutions we can look for while developing a robust method. Here we can see that both ethylene oxide and 2-chloroethanol are having very low molecular weights and are having a large difference in the boiling points and the vapor pressure at 20 degree. So we need to take care of the losses of the ethylene oxide when we develop the sample preparation method. And also, because of low molecular weights, there is a problem of selection of specific ion fragments, because at this much low masses, there is a lot of abundance of interfering fragments from nature, natural interferences. Also, we have less choice of fragments for selective monitoring of these two compounds. We'll just take a look at what all the reference methods are available. So what I have done is here we have divided all the available possible methods into the three categories with respect to sample preparation, sample introduction, and the detection techniques. Also, I have listed the possible options among each category, which are the configurations available. So for the sample preparation as per EURL single laboratory SRM method reference document, which is already explaining about Quechers and QOL method, which are using the triple quadrupole mass spectrometer as a detector. In EURL SRM reference document, they have also given the reference of conversion method developed and published by Banani et al. In 2006. We can also see that there is a mention of headspace method published by Woodrow in 1995. We have successfully reproduced all these methods in our lab without or with slight modification in the sample preparation or the method. And then we have studied the merits and demerits of these methods. So as we can see, the ethylene oxide and 2-chloroethanol are having the very low masses. So their mass spectra indicates very few fragments to be available for the selection. So here are some of the mass spectra of some possible interferences which can come with the EtO in GCMS or mass spectrometry. It becomes very challenging to differentiate within these compounds if they are not chromatographically separated, only on the mass spectra basis. We can see that 44, 29, and 16 are the three possible ions available for the ethylene oxide for the quantitation and the qualification. So there are many compounds having a similar fragments and closely eluting with ethylene oxide are there. So here I have listed some of them. So carbon dioxide, you can see it is having the masses of 44, 28, 16. Similarly, acetaldehyde is having almost all the similar masses with the ethylene oxide. So 44, 29, 16. And also methanol, you can see that it is having the 29 and 16 are the masses which are similar to the ethylene oxide. Similar way, we can see here the chromatographic elution pattern of ethylene oxide, acetaldehyde and methanol on different column chemistries. This indicates that how much closely they elute on the column and on the stable wax. They are co-eluting in fact. So even with the try of the different temperature programmings, it is very difficult to separate them because they are early eluting peaks and have a less margin to play along with the temperature program. And secondly, sometimes very much delay in the retention of the peak can distort the peak. So it is very difficult to rely only on the retention time basis, the identification and the quantification. So these are thus the representative chromatograph of some interferences. But in the nature, there are many volatiles which can co-elute or closely elute with ethylene oxide. So for all of our experiments, depending on the matrix interferences, we have used the different column chemistries, and also we have done all the experiments on triple quadrupole mass spectrometer. So first, we'll quickly go through the URL SRM reference method of analysis. So QOIL method and Quechers methods, these two methods have been given in URL SRM reference document. If you see the QOIL and Quechers method are almost same, except the two differences. One is QOIL is not using the Quechers salts for the extraction. That extraction step is missing, and it is using 95% of ACN with 5% of water for the initial extraction. Apart from that, both the methods are quite similar. So the QOIL methods are mainly used for the nuts and oily seeds, and Quechers method are used for the other matrices. So here we have to take care that the nuts and oily seeds, if they are bigger in size, we have to do the milling process to ensure the homogeneity of the sample and proper extraction. But during this process, we have to ensure that there are no losses of ethylene oxide or not. So we have to do a freeze dry milling. So under liquid nitrogen or any other technique which you can use. Here we are using basically using the sesame seeds for processing of the sample. So these are coming under the tiny seeds category, so we need not have to do this milling process, and we can directly take the sample into for the analysis. So as a first method development, we have taken the slightly modified QOIL method, and here we have used the 100% ACN for the preliminary extraction, and then we have done the cleanup, sample cleanup with modified Quechers cleanup with a magnesium sulfate PSA and C18 and GCB. And after that, we have centrifuged and use the supernatant solution for split-split injection and with the triple quadrupole as a detector. So these are the details of GCMS parameters we have used for the analysis. Here we have used VMS column, RTX VMS column with 60 meter, 0.45 and 2.55 dimensions. The GC column program starts from 35 degree to ensure the proper peak shape of ethylene oxide. We optimized this temperature conditions and kept on hold for 5 minutes. So after the ethylene oxide peak comes out, we have given a ramp to reduce the runtime for 2-chloroethanol. And this obviously can be further modified to reduce the runtime in later stages. Upper table is showing the MRM transitions, which we have optimized for ethylene oxide and 2-chloroethanol with their collision energies. So this slide shows the summary of the results obtained from this method. So we have plotted the linearity of the 5 levels from 5 ppb to 100 ppb, and we could achieve the linearity of 999 R-square regression coefficient. And the LOQ achieved was 10 ppb in this method with recoveries in between 70 to 120%. The RSD of at all the levels are much less than 10%. But we have found the recoveries for ethylene oxide to the slightly lower side, but still it is acceptable and consistent throughout the experiment. So throughout all the levels, and so this can be good enough to report. You can see even the linearity curves and mass spectra, overlap mass spectra here for both compounds. Then second method we have tried with the conversion method. So here also we have used a modified conversion method for conversion of ethylene oxide to 2-chloroethanol. So conversion reaction was carried out in a water bath by using sulfuric acid and saturated sodium chloride solution. The solution was kept in a water bath for about 50 degree around 3 hours. And then the mixture was cooled at -20 for 30 minutes, followed by the extraction with ethyl acetate. Then extracted supernatant solution of ethyl acetate was taken for treatment with sodium sulfate to remove the moisture completely. Then again centrifuge, and the supernatant solution was treated with the DSP and centrifuge at greater than 3000 RPM. So after that, we transfer the liquid aliquot, clear liquid aliquot to the tube for liquid as well as headspace analysis. So here we have performed the liquid as well as headspace both analysis. So here you can see the parameters which we have used for the liquid injection and the headspace parameters. So for both the headspace and liquid injection parameters, we have used the same parameters for GC and MS. The right hand side is showing the headspace parameters. So here we are interested in analyzing only 2C as a converted 2C. So we kept the vial incubation temperature at 110 degrees centigrade. And here we have used the Stabilovax DA column with 60 meter 0.25 dimensions. Here we have used the Shima2 headspace features of multi-injection count, by which way we could increase the sensitivity of the method. And the trap was kept at -10 degree during the adsorption process. And it was sufficient for the 2-chloroethanol adsorption. So this slide shows the comparison of liquid injection and headspace dynamic injection for 2-chloroethanol obtained from this method. So you can clearly see that the difference between the matrix interference in the case of the liquid injection and in case of the headspace injection. In the case of headspace injection, you can see much lower matrix interference observed. And this is because in the headspace technique, what we are doing is we are only allowing the volatiles and semi-volatiles to go through the system or column and the total GC system. We are restricting to go high boilers or some of the semi-volatiles to go into the system, which can cause the interference by controlling the temperature of the vial. So this is the biggest advantage we have when we use headspace method. So this is a summary table, and here also you can see that with the headspace dynamic technique, we can achieve better signal to noise ratio, better reproducibility, that is better RSD. By both techniques, we can achieve the good linearity as well as the LOQ of 10 ppb level. So recoveries are well within the acceptable level. In fact, it is between the 90 to 110%. So this method is proven for both the techniques, being said that the advantage on the dynamic headspace is much higher. Just to support our statement of interference with the headspace and liquid injections, so we have taken a much difficult matrix to study with the chili powder, and we have performed the similar analysis in the similar way, and we have done it on the liquid and headspace injection, both the techniques. So with the dirty matrix like chili, you can clearly see that the interference has been very high in the case of the liquid injection, and in the case of dynamic headspace, the chromatograms and the mass spectra are much clearer, and even the linearity are very, very within the acceptable range of 999. So in nutshell, there are a lot of advantages when we use the headspace sampler for the analysis of ethylene oxide and 2-chloroethanol in the matrix. It has a less contamination, very less or almost no sample preparation. It has less interference, less hazard, because we are not doing much sample preparation. So we are not exposed to ethylene oxide much. And we have a low maintenance. So it can improve the life of the consumables and also reduces the breakdown. So just to understand how dynamic headspace sampling happens, here I have prepared some animated slides to understand. So basically it happens in 3 different stages. So before the headspace process starts, or the sampling process starts, headspace sampling process starts, the vial first is incubated in the oven at a desired temperature to accumulate all the volatiles into the vial. And then there is the static vial pressure developed because of these volatiles. So on the understanding of the static vial pressure, we have to pressurize the vial more to ensure the complete transfer of the headspace volatiles onto the trap. So at the first stage, the step is the pressurization of the vial. So in the case of this pressurization of vial and all the processes, there is a 2 6-port valve system in the headspace dynamic, which is playing a role. And the vial pressurization happens in this way. It is shown in the brown line. So next step is the release of the pressure and transferring all the headspace vapors onto the cold trap. See, this trap is kept at the cold temperature, which you have seen in my previous method that we kept it at the -10°C. And the material which is not adsorbed on the trap is thrown out to the vent. So only the selective adsorption takes place in the cold trap. So this is mainly responsible for the reducing the interferences and also the concentrating the analytes to increase the sensitivity. As the third step, it is a desorption process. So in the desorption process, the trap is heated to desorb the material which is adsorbed, and then the carrier gas takes out the material from the trap. So it is the trap heated, and the carrier gas, which is a brown line, which takes up the material from the heated trap and injects onto the GC column for the separation and the analysis. The best thing here in Shimadzu system, the feature available is while this injection is happening, the analyte is going to the column and the GC run is happening, the whole remaining system goes into the flushing parallelly. So ensure that there is no carryover for the next run. So now, as we know the advantages of the trap system, so we wanted to see the effect of the results of this trap analysis on the results. So we have carried out the dynamic headspace analysis for in two different ways. So first is what we have done is we have done a simple sample extraction which we have done the extraction with the acetonitrile, and even we have not performed the cleanup process to check how much the matrix effect takes place or matrix interference comes if we don't do the cleanup treatment, and we can reduce that step. So we have taken just the acetonitrile into the vial and vortex for 15 minutes to ensure the complete extraction. And the supernatant centrifuge and supernatant acetonitrile 100 microliter we have taken into the headspace vial for this. So for direct headspace analysis, we have used these headspace parameters. The liquid injection parameters or the GCMS parameters were same as we have used for the last previous analysis. So only headspace parameters we have optimized for this method. Here we have used the multi-injection count 1 because using a higher multi-injection count can cause the distortion of the ethylene oxide peak. Also, we have used oven temperature 115 degrees centigrade, and the trap was kept at -10 degrees centigrade for the adsorption process. Here the good thing is that Shimadzu headspace shows the static vial pressure when the vial gets pressurized, so that we come to know the safer pressure range to avoid the vial bursting. So the static vial pressure is the vial pressure which is developed by when we heat the vial and the volatiles are accumulated in the headspace of the vial. So, and that also helps us to understand how much the additional vial pressure we have to give to the vial, where here it is indicated it's 192 which we have given. And this helps in optimizing the method to ensure the complete transfer of the volatiles onto the trap. So this is now the results obtained from this method. This is just extraction with ACN without cleanup. So you can see that even with only ACN extraction and we analyze by headspace, still the chromatograms are very clean and without much matrix interference, and also the linearities are obtained are 999. This is a 5-level linearity we have plotted. So here you can see the linearity is still from 10 ppb to 50 ppb, and the regression coefficients are 999 at all the levels, for all the levels. And then we have the 3 different levels, reproducibility and the signal to noise. So here also you can see that the signal to noise is sufficient to show the reliability of the method. And at the LOQ level, we have good recoveries within 70 to 120%, and the RSD is much lower than the 5%. So this is clearly shows the performance of the headspace, direct headspace analysis with just the acetonitrile extraction of the sample. And this works for the GCMS-HS. So we have tried 1 or 2 more matrices similarly, and we have got quite good results. So only thing is, as I said, we have to optimize the headspace parameters depending on the matrix which we are going to analyze. So secondly, we have used the direct samples, weighing of the samples in a vial, and for that we have used this method. So this is the second method which we tried on the headspace. Here now we have, what we have done is we have even not used the acetonitrile extraction of the sample. So we have taken directly the sesame seeds, weighed the sesame seeds 100 milligram into the vial, and then the pre-spike also sample which we stored in the refrigerator, that also we weighed 100 milligram similarly, and we have plotted the linearity by post-spike linearity in the matrix. So we have to just weigh 6-7 vials for 100 milligram of sesame seeds. And then we have performed the analysis directly. So here is the GCMS and headspace parameters. So for when we take a direct sample into the headspace vial, we little bit have to change the conditions. So here we have used the VMS column with 60 meter, 0.25 and 1.4 micron film thickness. Also here what we have done is split ratio we have kept 10 because we are taking direct samples, so there is a chance of other volatiles also coming out at a higher concentration. So we have wanted to avoid that. Then here, after 5 minutes of hold time with the initial temperature programming on the column, we gave a higher ramp of 30 minutes per second, 30 degrees per minute, sorry, and which will help us in reducing the run time. Also, at the end, we observe that we don't have to give a much hold time as a 5 minute because we are not getting the matrix as such into the column, and we don't need a conditioning of the column. So here, the second change what we have done is we have used the trap cooling or absorption temperature of the trap at minus 20 degrees centigrade to ensure the improved sensitivity. And the vials we have kept it at 10 degrees, 70 degrees centigrade. So these parameters we can modify depending on, again, the samples which are under the analysis. So here you can see the result obtained from the direct samples into the vial. And here also, here we have plotted the linearity of 3 levels we could do. And still we are getting a very good linearity of almost 999. And here is the overlay of the linearity, chromatograms of the overlay of the linearity. And then at the 10 ppb level, the chromatograms with the 2 reference ions and 1 target ion. So you can see the very clean spectra and mass spectra and the chromatograms here, which are obtained. So this method also proves that direct headspace sampling is possible, and the method by this method we can save a lot of time. Then many advantages we have of the headspace that, as I explained it before. So we can use headspace successfully depending on which matrix we are using. So some matrices you may have to do the acetonitrile extraction at least, but some matrices which you can take directly into the headspace vial and analyze. So it's very less skill required. So what I have done is, this is a summary of these results. So you can see that signal to noise ratio is also very good, reproducibility is very good, RSD is very good, and then we have done the sample in duplicate, which is well within 80 to 120% the recoveries for both the compounds. So this is a brief summary of whatever all the methods we have seen in this presentation. So there is a method with a liquid injection for both ethylene oxide and 2C by doing the quenchers or QIL extraction method. Then we have the conversion method, again with liquid as well as headspace injection system. And then we have seen the method with the headspace for both EtO and 2C by acetonitrile extraction and doing the headspace analysis. And then we have done the headspace analysis by using a direct sampling. That is, we have weighed directly the sesame seeds into the vial. So if you see this summary table, you can find that all the methods are comparable and showing a performance at par. So we are providing you the a la carte of the methods, and depending on the requirement, you can select the method in your laboratory and use it. So here in nutshell, I want to conclude or summarize the findings in one slide. Wherein what I have done is I have repeated the first slide with sample preparation, injection system, and the detector, and what are the different configurations available in the market, which I have shown you in the initial slide. The same thing I have compared for its merits and demerits. So more the green, the more the merits are there for that configuration, and more the red, more the demerits are there for this combination of the different configurations. So if you can see that direct sampling process, or little bit just the acetonitrile extraction, less sampling process with the headspace dynamic injection system and a triple quadrupole mass spectrometer, the detector is the best option available and recommend, because it has a lot of merits. You can see a lot of greens in that line row. And then the second option, the best option is quenchers or QIL extraction method, which takes care of the matrix removal. And then the splitless or PTV splitters or PTV injector, any one of those you can use, because both are almost similar. and then the triple quadrupole as a mass spectrometer for detection. So these are the best combinations I recommend. So all these we have developed not only on the sesame seeds or the food matrices, but we have a lot of applications to analyze ethylene oxide and 2-chloroethanol in various matrices, right from agriculture and the spices and Ayurveda medicines and the medical equipment. So what we are going to do is we are compiling all these methods which we have developed in one booklet, which is application data book, and that will be e-application data book. So it will be available in electronic format. And once we complete this book, will be available for the reference to all the lab chemists. So please stay tuned and stay connected with us, so that, and drop your email IDs or contacts in the chat box so we can send one of the copy for your use. So now we will be demonstrating you the experimental procedure for liquid as well as headspace extraction. So here are Mr. Sanket Chiplunkar from Shimadzu, who will perform the headspace analysis, and Dr. Reshma Patil from NRCG. She will be performing the liquid extraction and the liquid injection analysis on GCMS.
Good afternoon all. I am Sanket, an application scientist at Shimadzu Analytical India, and with me is Dr. Reshma, scientist from NRCG. Today we are going to demonstrate you the analysis of ethylene oxide and 2-chloroethanol in sesame seed matrix. Analysis of EtO and 2C is carried out with two techniques. Techniques are liquid and dynamic headspace. EtO and 2C reference standards are preserved in deep freezer at -40 degrees Celsius. Similar way, controlled and spiked sesame seed samples are also preserved in deep freezer at -40 degrees Celsius. Since this controlled sample is happened to be devoid of any EtO or 2C, part of it is used for spike recovery study. Other accessories and chemicals required for the analysis are shown here. Reference standards for ethylene oxide and 2-chloroethanol, controlled sample, 10 ppb pre-spike sample, headspace vial, syringe for headspace sample preparation, Tarson tubes for liquid sample preparation, cleanup reagent for liquid sample preparation, liquid vial, headspace vial autocrimper, micropipettes for sample preparation. Do not reuse headspace vial septa. As the septa is already pierced, chances of loss of ethylene oxide during vial incubation. We recommend to use headspace vial autocrimper as it ensures proper and uniform vial crimping and minimizes manual crimping errors. In this demo, we are going to show you comparison of two methods, dynamic headspace and liquid injection. Here, comparison is shown with regards to sample preparation time, sample cleanup process, and final outcome of the both methods. For both techniques, chromatographic parameters are almost similar. Liquid sample preparation is shown by Dr. Reshma on the right screen. Liquid injection sample method involves weighing of the 2 gram of sample, add 4 ml acetonitrile, followed by the vortexing, centrifugation and cleanup process. Dynamic headspace sample preparation is shown by myself on the left screen. Dynamic headspace sample preparation involves weighing of 100 mg of sesame seed sample into the headspace vial, add 1 microliter of acetonitrile and crimp vial tightly. In dynamic headspace analysis, different calibration levels are prepared by spiking respective level of standard stock into the sesame seed samples. So on the left hand side, we have prepared 1 ppm, 3 ppm, 4 ppm, 5 ppm standard stock solutions which are used for the spiking in sesame seed. On the right hand side, Dr. Reshma is showing sample preparation for the liquid method. On the left hand side, I am showing the sample preparation for the dynamic headspace technique. So here I am adding 1 microliter acetonitrile by using syringe into 100 mg of sesame seed sample which is already taken into the headspace vial. Then crimp vial with auto crimper. This is the sample preparation for headspace. Similar way, different calibration levels are prepared by spiking 1 microliter of respective standard stock solution into previously weighed sesame seed samples. On the right hand side, Dr. Reshma is continue with liquid sample preparation. She have already added 4 ml acetonitrile in sample and control sample. Next step in liquid sample preparation is vortexing. As per URL SRM analytical observation report, if the sample matrix is intact seeds, then we have to vortex the sample for 15 to 30 minutes. So here we are vortexing the sample for 15 minutes followed by the centrifugation process. We keep the sample for centrifugation at 10 degrees Celsius at 5000 rpm for 10 minutes. Next step in the liquid injection is cleanup process. One cleanup tube is required for 1 ml sample. We combine cleanup reagent from 4 tubes into one Tarsen tube, which is used for matrix blank preparation. Here, Dr. Reshma is adding 4 ml of the supernut layer from control sample into the Tarsen tube, which already contained cleanup reagent. Similar way, sample vials are prepared. Vortex the sample for 1 minute, followed by the centrifugation at 10 degrees Celsius for 5000 rpm for 10 minutes. Clean supernut layer solution is obtained. Both samples are now ready for the analysis. As trap method showed substantial reduction in time required for sample preparation without compromise on final outcome. This method has cutting edge over liquid injection method. Now first we will show instrument parameters to be set for dynamic headspace analysis. From system configuration, set up the instrument parameters. Sampler is headspace sampler. Injection unit is headspace. APC1 is used for pressurization of the wire. These are the headspace method parameters. We are using dynamic headspace, so click on the trap. And these are the parameters for headspace, such as while incubation temperature, trap cooling temperature, trap desorption temperature, while incubation timing, etc. These are the chromatographic parameters. This is the injection unit, this is headspace. Column flow is of 2 ml. Split ratio is of 10. And mode is split mode. These are the column O1 parameters. Then APC1 is used to pressurize the vial of headspace. These are MS parameters. Ion source temperature, interface temperature. Then these are the MZ and collision energies of ethylene oxide and 2-chloroethanol respectively. Resolution is used Q1 unit and Q3 low. Download the method parameters and then create batch. Create batch, acetonitrile, control sample, that is on spike, then calibration levels 10 to 50, then sample solution in a duplicate. Then start the run. It will ask for ecology mode. So after run completion, we want to cool down the system. So I said no. And run will start. This is a real-time demonstration how vial goes inside. As the headspace runs are going on, we have created method and sequence for liquid injection. Here we have used offline editor software to create method and sequence. These are the autosampler parameters. These are the liquid injector parameters. Here injector port temperature is 230 degrees Celsius, split ratio is 5, and remaining all other parameters are exactly like headspace parameters. Then we had prepared sequence for liquid sample analysis. Sequence is similar like headspace analysis. After completion of the headspace sequence, we had started liquid analysis sequence. After completion of the run, now let's see data integration of liquid process. Open Inside for GCMS. Then log in your credentials. On left hand side, there is an assistant bar. Go to the file, click on open. Change the file format to DAMLP. Open appropriate processing file. Here in one glance, you can see all the important data parameters. You can see R-square for both compounds and the data files used for plotting linearity and their levels. Now click on Import on Assistant bar to process all unknown data files. Firstly, we will import the diluent blank and unspike, that is control sample, to ensure they are devoid of analytes of interest. Then we will import sample runs prepared in duplicates. Now, as you know, we have spiked the sample with 10 ppv. Under parameter accuracy, we cannot see any value. Now, for obtain the recovery, we have to go to assistant bar, go into edit, click on edit tables and change the sample type from unknown to control. As soon as we do that, it will give you the recovery in terms of accuracy. Now to save the results, go to File and click Save As with different file name. Or if you want to overwrite, you can just click Save. Similarly, for HS data processing, open Insight. Go to File, Open, select Processing File in DAMLP, which already contains linearity data files as well as unknown sample data files. To obtain recovery or accuracy, click to Edit section on Assistant bar. Click on Edit Tables. Change sample type to control and click Edit Tables once again to see the accuracy results. To save these results and reproduce them as it is any time later, go to the file, click on Save. These are the summary of the results after processing of the data obtained from both the methods, which indicates that both the results are comparable with added advantages of dynamic headspace method.
Finally, I would like to convey my thanks to NRCG team and Dr. Banerjee for all the way coming to Mumbai and helping us in recording this experiment. Also, I would like to thank our SAIP team who have put a lot of efforts in recording and editing this experimentation and video. Thank you very much for patiently listening to the presentation. Yeah, I mean,
Yes, it's been a very great session, I hope, for everybody. Thank you, Dr. Kelkar, for the intricate details from the applications perspective, which are absolutely necessary for a successful estimation of EtO and 2CE at trace levels in very complex matrices. We have seen a varied matrices that you have already worked upon. So after a deep dive into the applications perspective, leaving no room for any doubts, we have also seen the live demo straight from Shimadzu lab to understand what the chemists have put in so much of work to simplify and provide appropriate solutions for this complex analysis. So all thanks to Sanket from Shimadzu Customer Support Center in Mumbai, and joining him was Dr. Reshma from NRCG Pune to, of course, demonstrate exclusively for all you analysts who are working on this emerging food safety concern. So we encourage you, still if you have left with any doubts regarding this, our expert panel of experts here are available for answering all your questions. All you need to do is just put in your questions in the Q&A section tab, which is there at the bottom of your screen. You will be able to locate it. You just need to put your questions there, and shortly during our panel discussion, following one more small session, will be answered by our expert speakers. And also, if you need a copy of the ebook just revealed by Dr. Kelkar, which will compile all solutions that are currently available, all options for you to decide what is the most suitable way for your analysis in your lab, you just need to patiently wait, and we will be sending you a link. You can type booklet in the chat or the section so that we know that you are interested, and we will make sure that as soon as the booklet is ready for download, the link will be sent to you. It will be shared to you. I think perfectly timed for a poll question so that we can have some interaction, because we would like to understand your opinion so that we can further provide or develop solutions so that you can overcome all the challenges that you face during your analysis in your lab. Let's do a poll question. Yeah. So the question is, do you feel liquid injection conversion method is most challenging in terms of reproducibility, or is it laborious? Which do you think? I mean, is it yes, no, or are you neutral about your choice? We will take another 5 seconds, waiting for all those people who are yet to make or share their choice. Okay, we'll end the poll now. And to share the results, what the results show us is that yes, definitely liquid injection conversion method is more challenging. Let us take one more poll question, since it was a long session. Which is on the best utilization of technology. So best utilization of throughput and minimal instrument downtime. What are the factors responsible? Do you think it is less contamination? Is it minimal sample preparation time? Or is it ease of data processing software? What is the most critical factor as per your opinion? Please participate. Let's make it interactive. Let us hear what are your challenges. Do not shy away to respond. Waiting for another 3 seconds. 3, 2, 1. Let's see. Okay, let me share the results with you. For best, yes, the answer is minimal sample preparation time is what is okay. The factor that you feel is most responsible, followed by less contamination, and then last is the ease of data processing software. That is great input. Thank you for the insight. Okay. So let's Let's move on to our final session. Let me invite Dheeraj Hande, who will explain to us the benefits of using the headspace trap for such kind of analysis. Mr. Dheeraj is working as Deputy Manager GCMS Product Marketing for Shimadzu India, based at Mumbai since 2008. He has over 19 years of experience in the analytical field. At Shimadzu, his role involves pre-sales and post-sales application support to pharma, food safety, flavor and fragrance industry customers pertaining to troubleshooting, method transfer, method development, validation, etc. His key areas to signalize complete system configuration with total solution related to GCMS instruments, along with accessories like headspace, uh, TD, pyrolyzer, etc. for all customers. To his credit, he has around 30 posters published in international conferences. Also, he has been actively involved in performance evaluation of various chromatographic and advanced technologies available with Shimadzu, as mentioned previously. Dheeraj, without any further ado, let us hear from you what are the advantages, and I'm sure it will be helpful to all our audience.
Yeah, thank you, Amy. Please let me know, can I see my presentation?
Yes, Dheeraj, carry on.
Okay. Good evening, everybody. Myself Dheeraj, and I will be talking about the Shimadzu solution on ethylene oxide in 2-chloro triple quadruple GCMS-MS and with the headspace. So in my presentation, I'm talking about the product line features of triple quadruple GCMS TQ8050NX and the headspace sampler, that is HS20NX, which is your best partner for your volatile samples analysis. So in our Shimadzu, we have a range of GCMS series. For triple quadruple, we have two models, GCMS TQ8040, which is a standard model of triple quadruple GCMS-MS. Then we have a high-end model, which is a high sensitive, that is GCMS TQ8050NX, triple quadruple. And in single quadruple, we have GCMS QP2020NX. But for ethylene oxide, we recommend to go for a triple quadruple, that is GCMS TQ8040 or 8050, because as ethylene oxide and 2-chloro are the targeted compounds, so you need to confirm whether that these two elements are present or absent in your sample. So triple quadruple will give you the confirmation whether that ethylene oxide and 2-chloroethanol is present or absent in your sample. So TQ8050, which is the top end model of Shimadzu, which is a high-end instrument, since the limits are to the lower side and it goes lower day by day, so we require a high-end instrument. So we have a TQ8050, which is having a new detector which detects a very few ions correctly, especially in a few femtogram level also. So like in 8040 and 8050, compared to 8040 and 8050, even if the few ions, if few samples are injected, you will get the same sensitivity in TQ8050. So like in 8040, you may have to inject more amount of injection volume, whereas that same concentration, less amount of injection volume is also sufficient in 8050. So when we compare the TQ8040 instrument detection limit, it is 4 femtogram, and TQ8050 instrument detection is 0.5 femtogram. So compared to sensitivity on the spec, 8050, it's 8 times better than 8040. So 8050, what we have changes, there is a special detector which is having a noise reduction technology, which decreases the noise even at a femtogram level. So here the noise is being reduced drastically. Before the ions enter to this detector, there is an overdrive lens also, which remove the neutral noise coming from your sample and carrier gas. So the lower the noise, the higher is the sensitivity. So you can see in this graph, when the 8050 is there, it's red color, when the shield is on, the background noise is very less compared to 8040. So 8040 you can go like up to picogram per microliter, that is ppb level, whereas 8050NX you can go still very low level, that is up to femtogram level you can detect. So the lower the noise, the higher is the sensitivity in our GCMS TQ8050NX. So this is a special noise shielding which is installed in our TQ8050NX. So as I mentioned, the lesser the injection volume when you inject in your TQ8050 compared to your 8040 model, like in 8040, you may need to inject a 2 microliter of 5 ppb. Same sample when you inject a 0.5 microliter of 5 ppb in 8050, the same response you will be achieving. So injection volume can reduce during the analysis, which will reduce the analytical loads on your insert, column, and ion source and other parts to reduce the maintenance. So like the injection volume less, the contamination will be less, your column life will be more, your insert will be not contaminated too much. So where 8040, you have to have some spares, okay? So because you will be injecting more amount of sample to achieve that level of sensitivity in your triple quadruple. So when you compare the TQ8040 and 8050, the specification wise, the EI scan sensitivity of 1 picogram OFN, the signal to noise is 1500 in 8040, whereas in 8050 it is 2000. Whereas EI MRM sensitivity for 100 femtogram OFN, the signal to noise is more than 18,000, whereas in TQ8050 is more than 40,000. And the majorly the EI MRM, the instrument detection limit, what we check for OFN, that is for 272 and 2222 transitions. That is for 8040 at 10 femtogram, we can achieve ideal, that is instrument detection less than equal to 4 femtogram, whereas 8050, the instrument detection limits we can achieve up to 0.5 femtogram, 40 femtogram OFN sample. So 8050 is more sensitive compared to 8040. So it's not like that 8040 cannot meet your criteria, 8040 can meet, but 8050 is a future-proof instrument. So in future, the detection should go below than 5 ppb also, it can be detected in our 8050. Then for headspace, we have a HS20NX. This HS20, officially it was launched in 2013, but the NX model, that is the black color, with the NX series, it was launched 1.5 years ago, the HS20NX. What are the major features of HS20? We have a platen and oven of 12 vials, means you can accommodate 12 vials inside this in an oven with the continuous heating is possible with shaking. Then oven temperature, the vial temperature, you can heat it maximum up to 300 degree. Then there is a loop, which is the standard, comes with the headspace, that is 1 ml loop will be there. The loop, we can heat it maximum up to 300 degrees centigrade. And the transference, short transference, there is a very short transference, which maximum temperature we can go up to 350. So Shimadzu is the only headspace where the temperature of the transference we can achieve up to 350 degrees. So it will remove any high boiler carryover coming in your instrument. Then we have a 90 vial rack tray. So you can put here 90 vials of 20 ml vial also, or you can put a 10 ml vial. The 10 ml vial does not require any adapter. The height of the vial is adjusted automatically inside in your oven. Then all vial is leak checked. It is not like only single vial will be checked for the leakage. If you put 90 vials in the sample tray, 90 vials will be checked for any leakage in the vial. So when you crimp the vial, if the crimp is loose, the gas goes out. The gas goes out means the response get decreases. So now instrument will tell you what has gone wrong to that particular analysis if the area got decreases, and the error will be occurred in that particular vial. It will show a message abnormal pressure is occurred because the gas has been released out from that cap. Then we have a dynamic headspace, that is a trap. The trap will be installed here. The lowest temperature of trap we can go up to -30 degree, and the trap heating we can go up to 350 degree. So whatever the volatile gas will be captured at very low temperature -30 degree, and the heating, the dissolved temperature maximum we can go up to 350 degree. Since ethylene oxide, the boiling point is very low at a 10 degree. So even in the room temperature, it may get evaporated. So you have to capture all the ethylene oxide present in your sample. So we require a highly cryogenic system which goes up to minus 30 degree in our HS20 trap. Then the unique selling feature of our HS20 is that we have a super short inner transfer length. So here you can see when it's connected to a GC, it is connected from the side. The transfer length is very short, it's hardly 30 centimeter length is there, and the column is connected directly to the transfer length. So in our transfer length, there is no liner, no glass wool, no sucta. So column is connected directly to the transfer, whereas this part will be used for the liquid injection. So the short transfer length minimize the adsorption in your analyte and maximize the suppression of the pre-broadening during the analysis. Even with the short transfer length, we'll get a higher recovery for the high boiling point sample analysis. Then the another unique feature which is added in our HS20 annex newly in this feature is added in our hardware, that is the flush point feature, where we have a unique isolation gas flow. So during the analysis, the venting line is separate and the gas sampling wall is separately. So in a conventional receipt, the same line is used for the sampling and the same line is used for the venting. So due to which the carry was occurring in the next one. But in HS20 NX, the venting line is separate so that during the sampling wall will be using the gas for the collection in the vial, whereas venting line will be totally different, where continuously the carrier gas will be passing. So there will be no back pressure and the carrier will be removed. So here you can see we have injected one DMSO as a diluent, and then afterward we have checked the water as a to check the DMSO carryover, in which we have not seen any carryover of DMSO in the water analysis. Then the another feature which is a patented technology in our Shimadzu, that is inverted oven. So in your Shimadzu HS20, you will see the vial which is entering to the oven, it will enter from the bottom. Whereas the normal headspace, the conventional headspace, the vial from the top, it will enter to the bottom. So here, this is the oven. For example, you have maintained a temperature of 80 degree. You know that always the heat escapes from the upper side. So when the vials enter from the top, the heat inside in the oven escape outside. So there is a temperature stability will occur. 1 second.
Dheeraj, are you there? I think just a loss of connection. Dheeraj, are you there?
Yeah. Sorry,
Okay,
the internet got disconnected. My slide is again visible.
Yes, visible. Please carry on.
So in HS20, the vial will be entering from the bottom. So here the heat will not escape outside. Whereas in conventional headspace, we'll see the vial is entering from the top. So there is a the stability in the oven will be difference will be there in the oven temperature. Whereas in our case, the temperature will be constant in our HS20. So this technique we have patented in our HS20 NX. Then we have an automatic overlapping function, that is for if you have multiple sample analysis where your headspace while heating time is more than your sample analysis time. So in HS20, maximum 12 vials you can heat at a time inside in your oven, even your GC runtime is going on. So like for example, your sample heating in your headspace while is 30 minutes and your GC runtime is taking around 7.5 minutes. So sampling time plus column oven cooling time approximately take 10 minutes. So first while it will enter to your GC headspace oven, it will take 30-minute heating. Afterward, it inject the sample. It will take 10 minutes for the analysis. So as soon as the 10-minute analysis is going on, the second will enter to the oven. So while the first analysis get completed, the second while sample is ready for the injection. Only the first while it will take for the time during the analysis. The second, third, fourth, fifth while will be in the oven, where it will save your analysis time every time. So it will improve your lab productivity. So automatically this while will be going to your headspace oven for the incubation. Maximum you can heat up to 12 watts. The advantage in our HS20 is that if you are giving a shaking in your headspace oven, shaking plus heating will be there in the all 12 vials. So that is a major advantage. If you are having a method with the shaking and heating in a single method, both can be accommodated in our HS20NX. So this is an automatic overlapping function which is available in HS20NX. Then dynamic headspace, as Dr. Kelkar also mentioned, that how does it work? So it's just a basic. I'm showing you. You have to heat that vial in a headspace oven, where the vial will be heated at a constant temperature and time. The volatile gas will be collected in this headspace vial, for example, like ethylene oxide or 2-chloroethanol in your sesame seed. Then the needle will puncture the septa. It will suck the gas. It will transfer to a adsorbent tube, that is a 10x tube. The tube will be kept at a very low temperature. We keep at a minus temperature. Maximum you can go up to minus 30 degree. So like first time it will take, then again from the same vial, second time it will take, third time it will take, maximum it will take up to 10 times. So if you want to go for very trace analysis, from that same vial, 10 times you can extract the VOCs from your headspace vial, and it will be going to your trap at a minus temperature, which will concentrate your trap at a minus temperature. Then we have to dissolve this, whatever is absorbed in this 10x tube, you have to dissolve it. So what you have to do, you have to heat it. So the trap tube is heated, and this concentrated headspace gas is introduced to your GC column for the suppression. So like in normal headspace, you take only 1 ml of gas, it is going to your liver. Whereas in trap technique, maximum 10 times extraction is possible with the HS20. It will concentrate your sample. So this electrocooling trap, the how we can achieve this minus 30 degree, this is the electrocooling trap. It works with the Peltier technology. We don't require any liquid nitrogen to be connected to your headspace. So electronically, we can achieve minus 30 degree. So no cryogen is required. Then trap heating up to 350 degree. So absorb at low temperature is minus 30 degree and dissolve at 350 degree. The default adsorbent which is available with the Shimarzu instrument, that is 10xTA. The 10xTA will be installed here inside in this HS20. Whereas optional trap is also available, that is carboxan 1000 trap is also available for very low volatile analysis. So when we compare the ultra sensitive analysis with the trap mode, the sample enrichment using a electrocooling trap, HS20NX with the trap technique can give you sensitivity of 10 to 100 times more than your normal loop technique. So this sample you can see for ethylene and ethane, where the boiling point is very less, minus 89, minus 100, you can achieve with the trap technique 5 times we have extraction we have done. Whereas same sample, when it was performed in the loop technique, the peak signal is very small. So if you want to achieve the higher sensitivity without enriching any increase in the concentration of sample weight, if same sample you inject in a trap mode, you will get a higher sensitivity. So it is like a future proofing your lab, the trap is suggested. So in future, if you want to go for PPB or PPT level detection, that is possible with the trap technique. So this is comparison with the loop and trap. Another example I have taken coffee bean sample, where the coffee bean sample was injected in a loop mode, which is a normal headspace sampler, in which the loop mode was maintained at 80 degree for 30 minutes. This coffee bean, the same sample when we heat at a trap mode, maintain at 80 degree for 30 minutes, means we have heat that while for 80 degree, the coffee bean for 30 minutes. You can see the difference of the peak intensity. So when you compare with the loop and trap, the intensity in the trap is much higher. So the trap tube selection guide, the trap tube looks like this, which will be installed in our HS20. The default trap which is coming in the Shimarzu is the 10xTA. It comes company installed from the Shimarzu, Japan. The other optional trap is Carbopag and Carbosiv S3, which is optional. You can go for a very volatile analysis for environmental samples. The HS20NX can be used for the environmentals for VOC in water or soil samples, analysis of semi-water in your wastewater. In pharmaceutical, headspace is used for the residual solvents and impurity. For polymer chemistry, it is useful for residual solvents and impurity from the packaging material, from the food packaging material. And the food and beverage, it is useful for analysis of food fragrance or any odd smell, off smell, which is coming from your food, that can be also analyzed by the headspace. Plus, headspace is also used in the forensic and toxicology for the alcohol content in your blood sample. So the HS20NX loop model, loop-wise, it is very plain, whereas HS20NX trap model, you will look like this. There will be a cut will be there. So if you purchase only loop model, it cannot be upgraded to trap. So initially you have to decide whether you want to go for trap. So when you go for a trap model, you will get the loop also and trap in a single system. So if you want to do any residual solvent analysis, you can do the analysis in a loop mode. If you want to go for a very low ppb level detection, like for example ethylene oxide and 2-chloroethanol, then the trap mode is used. So in the same instrument HS20NX with the trap mode, you can use loop and trap simultaneously. So we have a total solution for the ethylene oxide and 2-chloroethanol for food matrix using a liquid injection also and headspace. So if you're going for liquid injection, we have a AOC 20i headspace, we have a HS20NX. So when you keep the GCMS triple quadruple on the table, so it will look like this: GCMS TQ8050. Then on the right hand side, there will be HS20NX. It will be connected from the side of the GC. GCMS will be used for the pesticides, and headspace with the trap technique can be used for ethylene oxide and 2-chloroethanol for the impurity analysis. Plus, the GCMS can be used for another toxic impurities in your food sample. Plus, you can analyze a residual solvent analysis in your with the loop technique. When you connect the column to the injector port and to the MS for pesticides or for ethylene oxide in the liquid injection mode, as per the URL method, we have to connect in this direction. When you connect the column to the headspace to the MS, the column is connected directly to the transfer line, another is connected to the MS. So in Shimarzu, as I mentioned, the column is connected directly to the transfer line. So we are not connected to this injector port. So we have a dedicated injector port for the headspace where the column will be connected from the side. So if you are using the same injector port for the headspace, then the contamination of the liner of the previous injection will go to the headspace analysis. So to avoid that, Shimarzu have made a design that this injector port, spitless injector port, will be used dedicated for liquid injection, whereas headspace injection port will be connected from the side. So the scientist or the chemist will know when you want to do the headspace, the column will be connected to the side of the GC. So here, as I mentioned, there will be no liner, no glass wool, no septa. So column will be connected to your directed transfer line. So your consumable cost will be also saved. And the other end will be to the MS. So this was GCMS TQ8050NX with the HS20, which can meet the URL method, the lowest ppb level detection for ethylene oxide and 2-chloroethanol. Thank you.
Thank you. Thank you, Dheeraj, for the effective insights on the technology side. Now let us quickly have one more poll question. What would be the best part offered by Shimadzu's cutting edge technology and solutions? Do you think it is the hardware? Do you think it is the software? Do you think it is the support that Shimadzu provides its customers? Or do you think all these factors are important? Let us have your response so that we can focus on exact preferences that you may have. Waiting, counting till 10. Three, two, one, ending the poll now. Thank you for your responses, and let me share the results with you. Of course, all aspects are equally important for your successful analysis. Yes, that is very clear. Let us have one more poll question, which is what we would like to understand based on your insights that you've gathered today on this webinar platform. Which method and technique of analysis will you prefer? This is the most important question that we would love to understand. This is most critical, and I'll be waiting for gathering maximum responses. It's very important, very critical for us to understand, to provide you the right solutions, to help you overcome all the challenges that you may encounter for analysis in your labs. Is it Quetcher's method? Is it QL method? Conversion method? Dynamic headspace method? Which one are you going to prefer to implement in your lab? Okay. Thank you. And yes, let me share the results. Yes, here are the results. Yes, people are definitely interested in the dynamic headspace method. Our team has surely made note of it, and we welcome you to feel free to contact us, write to us, request for any further discussions on the subject, or if you would wish to request any customized analytical solutions. Our email ID and the web address is already posted in the chat box for your reference. So before we, it's now time to answer all your questions that may have still been residual after such an enlightening session. I would like to invite all our expert panel speakers to come on board or unmute when you're talking, put your videos on, and be available to answer all the questions. I would also like to invite Dr. Rasam from our Customer Support Center, Shimadzu, India, based in Mumbai, to moderate this session for us. Quickly, we will like to address all the queries that you have raised. Inviting all speakers, expert panel, along with Dr. Rasam.
Okay, thank you. Shall I start?
Yes, please. You can take and pose the questions and initiate the panel discussion.
Okay, fine. So good evening all. And this is Dr. Rasam here, moderator for Q&A session. In fact, our webinar is happening at very apt timing. Okay, at just day before yesterday, we celebrated our 75th India Independence Day. And this particular webinar is one of the initiatives by NRCG in collaboration with Shimadzu under the banner of Azadi Ka Amrit Mahotsav. So hope that you liked our webinar, and we also believe that it was very much enriching and insightful. So I could see in the chat box there are many questions, and that simply means that people were attentive throughout the webinar, and they are now more curious to know about the answers from our expert panel. So I have gone through all the questions in the chat box, and one might have noticed that our experts, they already have covered all these questions in their respective talks, or if not, they have answered in your question and answer chat box also. So we at Shimadzu would definitely love to answer all your questions, but in the interest of time, it will be very difficult for us to take all the questions, but be rest assured that we will be sending answers to all your questions through the registered mail ID that you have shared with us. So please be rest assured. And now, without a further ado, let me take the first question. So as most of the questions have been answered, so I have one question to Dr. Banerjee, sir. In your presentations, you just highlighted us or you just briefed us about the regulations. So is there, sir, any possibility that in near future, we can have the harmonization on the requirements of all these MRL values? Okay, because we deal with many regulatory bodies, overseas also and domestic also. So is it possible to get the harmonization done and let us have one particular MRL for respective commodity? Or if not, what are the difficulties these regulators are facing? So I would like to hear your view on this. Dr. Banerjee,
Yeah,
sir, please.
thank you, Dr. Rasam. This is a problem every country faces, but you know that this is the difficulty because every country has their own regulatory system. The food consumption pattern is different. So in many cases, the exposure of pesticide in a particular country may be different from other countries. So that is the hindrance in harmonizing MRLs. And the second point is that for compounds like ethylene oxide, which are basically not legally permitted, they are used illegally. So in such cases, there is no risk assessment because no one has treated them as per requirement. People know that they have antimicrobial property and people have exposed the food items against those such compounds and getting the products micro-free. But problem is that the residue of ethylene oxide remains persistent, not only as such, but also in the form of 2-chloroethanol. So under this situation, you saw that initially people thought that 0.1 ppm will be the value, which was a little bit higher side because at that time method was not optimized. In the chat box also, you might have seen that a lot of questions are coming that people are talking about lack of repeatability, lack of reproducibility. So these are problems with such type of volatile substances because they are not that stable enough. And the compound is also such a small molecule. It is not easy to analyze these compounds. So in one answer, I also mentioned that a lot of effort is required. Today, whatever people have seen, these are the results of a lot of effort, which our team, means both Shimarzu as well as our lab, they worked since many weeks. Harmonization is difficult because as soon as people comes out with some newer technology or instrument becomes more sensitive, someone may bring down the limit because there is no risk assessment. So people say that let us monitor such chemicals at limit of quantification. So currently 0.02, 0.05, 0.1, these are the values in most cases. But it's possible that it may also go down to 0.01 or further low. So these are the main difficulties. So harmonization, I don't think is possible. Only thing is that we have to improve our analysis method in such a way that probably in future we can get more and more sensitive approach. And we are very happy that analysis is quite stable. We get very good repeatability, reproducibility. So this is fit for purpose method for regulatory testing. So that is the way we are currently happy regarding both liquid injection as well as headspace injection.
Yes, fully agree, Dr. Banerjee, sir. And yes, we have the practical difficulties in the harmonization. So we do agree with your views also. So do you, Dr. Kelkar, do you like to share or your views on this particular aspect?
Yeah. Actually, see what Dr. Banerjee sir said is perfectly correct. Because one more point is there because every country has different eating habits, and basically MRLs are set on a practical basis for daily intake. So daily intake at in every location is different. So like you see in even India, if you go to south, the rice eating is more. So if you ask them what should be the MRL for rice, it will be lowest one, they will say, because they eat rice in a very high quantity. So their daily intake will be high if you keep the MRL high. And if you go to north, they will say, oh, I want wheat MRL should be very low. So it depends on the safety finally. So as Dr. Banerjee said, this harmonization will lead to the harmonization of eating habits, and that will be very challenging. It is not possible. And that's why harmonization is very challenging and difficult. Also, there are TBTs involved, trade barrier.
Yes.
And so a lot of things are involved internationally when we try to harmonize it globally. So I agree to his point that harmonization of limits is difficult. Yeah, but we can harmonize the analytical testing methods. So that every country will test as per that similar method or same method, which can be a gold standard, so that there is no ambiguity that one should follow which method and then results are different. So this should not be there. Although the validation and everything has been tested, still the people are always in dilemma. So which is the right method I should use? So that I think maybe Banerjee can put a view on this, but method harmonization can be done. So that can be a standard methods which can be referred to with different laboratories.
Okay, thank you, Dr. Khilkar. So the next question is, most of the questions have been answered, but still this is a very good question, I feel, about the ECD. Is ECD sensitivity comparable to GCTQ in case of 2CE? Can we achieve 2 ppb LOQ with ECD? So already,
I think Dr. Banerjee sir and myself, we both have answered this question already.
But
so rightly said, we both are saying the same thing, because Banerjee sir also said that it is not a specific, too specific like MS, because all the chlorinated compounds or electrophilic compounds will show the response. Okay, so it is not based on the mass fragments or mass spectrometer. So it is not too selective for that. It is a selective for one group. Okay, that is a chlorinated compounds or electrophilic compounds. So whatever the electronegativity compounds comes in the picture, they will interfere. And there are many compounds like this in the nature. And when we are dealing with the natural products, it is bound to happen and come with the matrix, along with the matrix, these compounds. And today or tomorrow, we are going to face a challenge and a problem. And as ethylene oxide is very early eluting, so a lot of interferences can come. A lot of volatiles come in that region. So as I said in my presentation also, it is very challenging, not difficult to do it with ECD.
okay, thank you. So there is one question for Mr. Sanket. Is it necessary to use centrifuge with temperature control setting for the sample preparation? Sanket, though you have answered this question, I would like you to please elaborate more on this based on your practical experience.
Sanket, please unmute yourself.
Your voice, I think.
Sanket, you're not audible.
I think his voice is not some problem. Yeah, Rasam, you can go to the next question.
Okay,
Maybe one question I saw that AOC 6000. Maybe Dheeraj can be the right person to answer this.
So Dheeraj, is that HS20 method also applicable for AOC 6000?
No, sir, because HS20, we are using a dynamic headspace, whereas in AOC 6000, it's like a static headspace they have currently. So we develop the method in a dynamic headspace that get trap mode. So it's applicable only to dynamic headspace. Though in AOC 6000, there is an option of ITX, but again, it's a gas type syringe technique. So there will be challenging because ethylene oxide is a very low volatile. During the transfer in the injection port, there is a chances the loss of gas may occur. Whereas in our HS20, it's a fully closed system, so there is no chances of any leakage from anywhere. So we recommend to go for HS20NX rather than to AOC 6000.
Okay. Thank you, Dheeraj.
I think Sanket is back. Sanket, can you now speak?
Sanket?
Still we cannot.
No, still we cannot. Okay.
Anyway, maybe I will answer on behalf of him.
Okay,
Try to
okay.
answer.
Hmm.
See, basically, centrifuge has to be done in cold condition for particularly ethylene oxide like compounds, because when we actually do the centrifugation, what happens, slight heat is created because of the centrifugation, and at that time, if you don't take care of the temperature, then there is a high chance of losing these low volatiles like ethylene oxide, and then you may get the lower recoveries, and there the problem can happen. So it is better to do it at a controlled temperature conditions. So we are doing it at a 10 degree. That is, even you can go to the lower if you want, but 10 degree, we have found that it is giving good recovery, no loss.
Okay, thank you.
Banerjee sir, you want to add anything?
No, it's fine. Perfect.
Okay, okay. Now, almost all the questions have been answered. So one more question from my side to the panelists, especially to the our scientists who have been working in this particular analysis in our lab. So dealing with such type of analysis, which is very low volatile in nature, having boiling point very less with a higher vapor pressure. So based on your experience, what one has to take the precautions with regards to the overall condition of the lab area or the overall atmosphere in the lab premises? Because we are dealing with such a low compound which has got molecular weight also very less. At the same time, it has got very high vapor pressure. It is very low boiler. So it can escape any time during the analysis, right? So what would be your suggestion to the audience, that what precautions they use to take care while doing this analysis?
So let me answer it. I think Sanket has shown it in the beginning of the video that everything is kept in a deep freezer at low temperature, and everything should be done under closed condition, because if you open it, then the compound may escape, and then temperature has to be quite low. Otherwise, during sample preparation, the compound will escape. Even during auto sampler injection, many times in India and other countries, people use that cut slit, that septum. So that is not a good idea, because in that situation, with passage of time, if the temperature of the room is not maintained, then there could be loss of compound. So these are certain things which are basically good practices in the lab. And we are dealing with one highly volatile compound and another is a non-volatile compound. So non-volatile compound, there should not be any problem. Highly volatile compound, chances of contamination is much higher, and the chances of escape is much higher. And our main problem is not with 2-chloroethanol. Our main problem is with the ethylene oxide. And please remember that during our analysis, we should not do anything by which our ethylene oxide residue level goes down because of our wrong practice, or because of our lack of effort. It should not be contaminated by something else, maybe some atmospheric signal or whatever. So these things are very important, that we should have clean atmosphere. We should have proper refrigeration system. That's the reason centrifugation is also done at low temperature, because at any point of time during sample homogenization, during rest of the sample preparation, during analysis, wherever possible, please maintain the temperature as low as possible. Especially temperature should be below 10 degree, because above that there is every chance that ethylene oxide level will go down automatically because of physical loss, which we should not allow to happen. So these are certain simple tips for ethylene oxide analysis.
Yes, yes, Dr. Banerjee sir. Thank you very much for your very thoughtful insight on this particular subject. So I think we are left with no more questions. So though we have covered everything, and as per the poll results also, whatever audience they are expecting solutions from Shimadzu. So we have everything. And in fact, when this started, this particular thing started, we run the EtO campaign only, and we are ready with the solutions. So we have whatever customer is demanding, we have all the solutions with us. So I request most of our esteemed customers to have interaction with our business partners also, and get your questions addressed through our unique solutions with our cutting edge technology. So again, back to Dr. Banerjee sir, though you have covered everything, but since you are our chief guest, I would like to hear from you the take home message to our participants in very brief, although we have covered everything, but still pertaining
It's a
to
difficult
this
task.
particular, sorry.
That's a difficult task. Take home message is that do good when you do analysis. When you are analyzing anything, whether it is ethylene oxide or any pesticide residue, please remember that based on your result, the fate of a farmer, fate of an exporter will be decided. So your analysis result, if it is less accurate, then because of some fault on your part, maybe someone else will face financial loss. So there is a big social commitment from our side, which is expected from any analyst. So please remember that it's not similar to analyzing a food product for nutritional parameters. These are contaminants. These are related to food safety, and these are highly regulated subject. So every time you analyze, the concentration estimated will be compared with the regulatory limit. So if it fails, then material has to be destroyed. So such kind of scenario should be in the mind of an analyst and the entire laboratory chain, so that we are responsible enough while optimizing the method, while validating the method. And once the method is properly optimized and validated, probably you don't have any other tension, because then the method will perform automatically. Because these days the instruments are very stable. We don't have any repeatability, reproducibility problem in instrument performance. Main problem could be in your sample preparation. So under sample preparation, if you control all the variability factors, then probably your analysis result will be accepted by everyone. And that will help the entire industry, and especially the farmers, the stakeholders of agriculture industry, for which you, I, everyone is working, and on which our sustenance of life is also dependent. We are dependent on farmers. They grow crops for us. So analytical chemists should do their best to support the community. So this could be my message. Thank you very much.
Yes, thank you, sir. Yes, and yes, in my opinion also, having a sensitive technology in the laboratory has got no meaning if you do not have the other required equipments or the accessories and the skilled manpower. That is also equally important, right?
Exactly.
Because sample preparation plays a vital role in any type of such analysis at such a trace level. So Dr. Kelkar, would you like to share your views and your take-home message to our participants?
Yeah, as Banerjee sir said, there is no take-home message, but as Banerjee sir said, I would just want to add 2 points. One is that regarding the food safety and the matters related to export, now we are celebrating 75 years of the independence. Whenever the rejection happens from EU, it is a loss of country also, because it is a trade barrier. So whenever something is rejected from Europe or any foreign country, and because we are exporting in the bulk quantity, Dr. Banerjee is the right person. He has seen the rejection of the grapes from long time before. He has done a miraculous job in this and participation, and he has reduced the rejection of the grape export to 0% almost, and the credit goes to his all efforts. And when you hear such things that now the rejection is stopped from the foreign country for Indian export, you can imagine how economical effect happens on the country. So because more export will give more currency to you and more economy will improve. So I think we need to keep that in mind on this 75th independence anniversary, and we all should now pledge that here onwards, no manipulation for export testing, and no wrong reporting. And we should work hard so that nobody can challenge Indian testing lab reports. That's only I would like to say.
Perfect.
Okay. Thank you, Dr. Kelkar. So, dear participants, those questions in the interest of time we could not answer. Don't worry, you will get the answers from our panelists through the mail ID. So thank you all. And I think we'll stop here with the Q&A session. So thanks all the panelists for sharing your views, your expertise, and answering all the queries with elaborate explanation wherever required. So I highly appreciate it. So thanks to all panelists once again. And here we conclude the Q&A session. Okay. So over to you, Amy. Thank you.
Thank you very much. It was definitely very interactive and I am sure very insightful for all our attendees. Of course, we would like to formally thank each and one of every attendee. Can I request Mr. Bhagat from Spinco Biotech, Shimadzu Partners for GCMS range of instruments in eastern part of India, to please deliver the vote of thanks.
Yeah, just before this, sorry, Bhagat. Just before this, I want to request Banerjee sir, if Reshma and the team who were there with Sanket for sample analysis and all, can they switch on their videos? Can we do, I mean, can they come on the screen?
Sir, I think they have to be promoted as panelists for being able to.
Can we do that? Because I wanted the team to be shown who were behind the scenes.
I can try.
For
me the names.
doing all this work.
I will try.
If possible, within 2 minutes. Otherwise,
because
okay.
We have almost 200 attendees, and I need to identify to be able to promote them.
No, if it is difficult, it's okay. No problem. But just I would like to.
I guess. Would you like to flash the photo again?
Once again, you can display your slide. Wherein you showed the,
okay. I will.
People behind the scene.
I can see Dr. Reshma. Okay, I can promote her to panelist. I mean, I hope it is Dr. Reshma. If you can try to switch, unmute. Yes, that's working. Anybody else? If you can give me the name, I'll try my best to identify them in the. Dr. Reshma, you can unmute yourself, put on your video on, and meet with our attendees.
Yes.
Yes, Dr. Reshma.
Thank you. Thank you very much, Dr. Reshma.
Yeah, we really appreciate.
For supporting. So maybe Bhagat can start.
Bhagat, you are on mute. Yes.
Yeah, good evening, Team Shimadzu, and to all the dear customers. I would like to express my thanks to all esteemed delegates of the webinar for their presence and contribution while making this webinar a great success. Another webinar, another success. So to start with, I extend my gratitude for accepting our invitation and for being here with us today. Our honorable chief guest, speaker with a keynote address, Dr. Kaushik Banerjee from NRCG. Thank you, sir, for taking time out from your busy schedules. You did set a perfect tone of the webinar, like always. Your thoughts were perfect to the context. So thanking you once again, Dr. Banerjee. It was then the turn of Dr. Kelkar, as the name symbolizes, Kel, okay, as the name symbolizes. He played well with a perfectly framed application presentation. So in short, Dr. Kelkar, your presentation was worth an EtO 2CE Kel Ratna Award. Okay, thank you for that. Then comes the demo session from Sanket and Dr. Reshma Patil from NRCG. Wow is the only expression I can ever have. Spellbound to this perfect Jugalbandi, I would say, with an absolute precision, demonstrating the minutest details. So my special appreciation to you both for steering this session to a clinical perfection, we call it as. And then comes the trap, the true innovation from Shimadzu, the way we live with the way we call excellence in science. Thank you, Dheeraj, for enlightening us with this very unique ability of Shimadzu, which only Shimadzu has. Trap is truly proprietary, rather a breathtaking innovation from Shimadzu for today's ever-increasing sensitivity needs in every application, be it pharma or food. So trap is the only solution which can address the today's and tomorrow's sensitivity needs. So in short, the HS20 trap is the Talaiva of headspace technologies, the big brother, the southern style of Talaiva, we call it as. Of course, I have seen close to 400 plus participants today. Half of them now at this point, half of them are available. Explains the importance of this trending application. I'm sure all the participants would have appreciated Shimadzu solutions, thus making the event and topic highly relevant to today's needs. So last but not the least, thank you, customers. But for you, we couldn't have come this far. Your presence here today testifies how you really love and believe in Shimadzu solutions. Looking forward to connect with you digitally for more relevant and trending applications. That's all, and a happy evening to all.
Thank you, Bhagat. And I really hope that everybody in Shimadzu hopes that this session was fruitful for all attendees, and it has definitely simplified your analysis, moved you a step closer forward towards successfully encountering all the analytical challenges to ensure the food safety, quality of your food products. So thank you all for joining us today, and hope to see you soon in another Shimadzu webinar. Stay tuned for more. You can follow us on LinkedIn. The link is already provided in the chat box. Please like and follow us so that you are updated with all our latest solutions. And please stay safe, everybody, and see you soon. Thank you so much.
Thank you, Amisan.
Thank you all.
Thanks,
for your-
everyone.
Bye-bye.
Bye-bye.
Thank you. Thank you, sir.
Thank you,
Bye-bye.
everyone.
Thank you.
sir.
Bye-bye.